Module 4, we'll talk about factoring polynomials. So when we're factoring polynomials, what we're doing is we're breaking down a polynomial into what values were multiplied times one another to get the result. So the first concept we're going to deal with is factoring out the greatest common factor. So the greatest common factor is the largest number or value that divides evenly into all the terms in discussion. So this first problem says factor out the greatest common factor of 45 and 15. So what we're looking for is the largest number that divides into both 45 and 15. So we know that 45 can be divided by 15, and 15, of course, can be divided by 15. So that's our greatest common factor. Only one of the terms has an x, so x would not be a part of our greatest common factor. So what we'll do is, we've decided our greatest common factor was 15. So we'll take whatever our greatest common factor is and place it on the outside of parentheses. Next, we'll divide each term by the greatest common factor. So we'll start with 45, and 45 divided by 15 is 3. Next, we'll divide negative 15x by 15, and that gives us negative 1x, or just negative x. So in its factored form, our answer would be 15 times the quantity 3 minus x. You can always check your answer by multiplying, or in this case, distributing. So 15 times 3 is 45, and 15 times negative 1x is negative 15x. And that matches our original problem. So you can always check your answer. So the next problem, it says factor, and in this case, be sure to factor out the greatest common factor of 5y squared minus 15y. So when we're factoring, we remove the greatest common factor. So what you do is you look at the coefficients first, the 5 and the 15. What's the largest number that divides into 5 and 15? And that would be 5. Now, since both terms have a y factor, we're going to take out a y. We always take out, if it's common to all the terms, the one with the smallest exponent. So here we have y to the second, and here we have y to the first. So the one with the smallest exponent is y to the first. So we take out a y to the first. So our greatest common factor is just 5y. So we're going to divide this out of each term. So 5y squared divided by 5y. So we look at the coefficient. 5 divided by 5 is 1. Here we had 2 y's, and we took 1 out, so that would leave us with 1 y left. Next, we'll take negative 15 divided by 5, and that gives us a negative 3. We had 1 y, and we took 1 y out, so there's no y's left. So this would be our answer. Now, in writing your answer, if you have a coefficient of 1, we usually don't write that. That's understood. So our final answer would be 5y times y minus 3. And again, you can check your answer by distributing. 5y times y is 5y squared, and then 5y times negative 3 is negative 15y. And that was our original problem. Our next problem, again, we're going to remove the largest possible common factor of 12x to the 5th plus 20x to the 4th plus 8x cubed, or to the 3rd power. So again, what you're going to do is compare 12, 20, and 8. What's the largest number that divides into all three of those? And that would be 4. Now, each term has the variable x. How many do we take out? We take out the one with the smallest exponent, which in this case is 3. So our greatest common factor is 4x to the 3rd. Next, we divide this out of each term. So the first term, we have 12x to the 5th. So we start by dividing 12 by 4, and that gives us 3. Here we had 5 factors of x. We took out 3, so that would leave us with 2 factors of x. For the next term, we have 20x to the 4th. So we have positive 20 divided by 4 is positive 5. We had 4 factors of x. We took out 3, so that leaves us 1 factor of x. Our last term, we have positive 8 divided by 4 is positive 2. We had 3 factors of x. We took out 3 factors of x, so no x remains. So our final answer would be 4x cubed times the quantity 3x squared plus 5x plus 2. Our next problem, again, we're factoring out the greatest common factor. We have 5x, and inside parentheses, we have a plus 9b minus, in parentheses, a plus 9b. What I'd always recommend, if there's no factors shown, it's understood in this case to be a 1 or a minus 1 in front of the minus in a plus 9b. So when we're removing the greatest common factor, remember, it's a factor. That's something being multiplied that's common in both terms. So when we look at this problem, you should notice that a plus 9b is common to both terms. So that's our greatest common factor. So in this case, we're going to take out our greatest common factor, which is a plus 9b. And now we have parentheses, and we divide that out of each term. So when we have 5x times the quantity a plus 9b divided by a plus 9b, what happens is the a plus 9b reduces, and that just leaves us with 5x. In the second, we do the exact same thing. So our greatest common factor is a plus 9b. So when we divide this term by a plus 9b, excuse me, that would leave us with a minus 1. And that would be your final answer. So our next example, we're factoring a polynomial with 4 terms. Anytime we have 4 terms in this class, what we're going to do is a process called factoring by grouping. So we're going to incorporate what we just talked about in the previous 4 examples into factoring this polynomial. So when we factor by grouping, what we're going to do is put the first 2 terms inside parentheses together. And then we're going to group the second 2 terms inside parentheses together. Notice I brought the sign inside. So next step is I'm going to remove the greatest common factor of each of these groups individually. So I'm going to compare x cubed plus 4x squared. So the only thing that divides into the 1 in front of the x cubed and the 4 is 1. But you notice that both of these terms have an x. So I'll take out an x, and remember you take out the one with the smallest exponent. So I'm taking out an x squared. So now when I'm factoring out, I had 3 x's, I took out 2, so that leaves me 1x. For the second term, I didn't factor out anything that would go into the positive 4, so that remains positive 4. I had 2 factors of x, and I took out 2 factors of x, so no x is left. So when I factored out the greatest common factor, it leaves me x squared times the quantity x plus 4. So in the next group, I compared positive 5 and positive 20. Now, a rule of thumb that we're going to use is whatever this sign is what we're going to factor out. So in this case, we're going to factor out a positive, and the greatest common factor of 5 and 20 is 5. The first term has an x, but the second one doesn't, so I can't take out an x. So what I'm going to do is divide each term by positive 5. So the first term, when I divide by positive 5, that would just leave me an x. In the second term, I'm dividing positive 20 by positive 5, and that gives me a positive 4. Now notice, what we have in parentheses is exactly the same. If you're doing this process right, it will always be the same, signs and values. So now we're going to finish this problem by doing what we did in the last example. We look inside and notice that our greatest common factor is x plus 4. And when we factor it out of the first term, it's going to leave us an x squared. And when we factor it out of the second term, it's going to leave us a positive 5. So our final answer would be x plus 4 times x squared plus 5. Next example. Again, we have 4 terms. So anytime we have 4 terms, we're going to factor by grouping. So what I'm going to do is put parentheses around my 2x minus 6 and parentheses around the plus 7xy minus 21y. So in my first group, the only thing that divides into 2x and minus 6 is a 2. So I factor out a 2, and 2x divided by 2 is x. Negative 6 divided by 2 is a minus 3. In my second group, again, since this is a positive in front of the 7xy, I'm going to factor out a positive. The greatest common factor of 7 and 21 is 7. Only the first term has an x, so I can't take out an x, but both terms have a y, so I can take out a y. Now I divide it out of each term. So if I have 7xy divided by 7y, that leaves me an x. And when I divide negative 21 by positive 7, that gives me a minus 3. I had one factor of y, took that out, so there's no y left. And again, very important, they both have x minus 3 left inside parentheses. That's how you know you're all right. So now our last step is to remove our greatest common factor, which is x minus 3. When we divide that out of each term, we're always going to be left with what's on the outside of the parentheses. So in this case, 2 plus 7y. Our next problems deal with factoring trinomials. And something about these that I'm going to talk about more in a minute is that if you look in front of the x squared, all of these only have 1, the number 1 in front of the x squared. So it's 1x squared plus 4x plus 3. It's 1x squared minus 7x minus 8. And that's going to be important because there's going to be a shortcut to factoring these problems. But let's talk about the process of factoring before we talk about any shortcuts. So we're going to talk about a process called the AC method of factoring, or sometimes referred to as the reverse FOIL method. So why is it called that? Because when we have the standard form of a polynomial, we have ax squared plus bx plus c. So we're going to be talking about the value in front of the x squared, and we're going to be talking about the constant or the value in front of our third term. So let's talk about the process. So the first step in all factoring problems, not just these, but in all factoring problems, is to remove the GCF. Whether they tell you to in the instructions or not, you're looking for a value that divides into all the terms. After we remove the GCF, if we're dealing with a trinomial, 3 terms, which we are in this case, we're going to use the AC method. So let's talk about what we do in the AC method. We're going to take the leading coefficient, and we're going to multiply it. So the leading coefficient, remember, is that a, the value in front of the x squared, and we're going to multiply it times the coefficient of the last term, which in this case we're calling c. Okay, so in this case, I'm multiplying 1 times 3, and I get a positive 3. My next step is to write all the possible combinations of the answer to step 3. So to get a positive 3, I could have multiplied positive 1 times positive 3, or negative 1 times negative 3. Okay, I'm going to choose the factors that add to the middle term. So in this case, positive 1 plus 3 is positive 4. Negative 1 plus negative 3 is negative 4. The two that add up to my middle term, which is a positive 4, is positive 1 and positive 3. So my next step is to rewrite the middle term using those factors. So I'm going to rewrite this as x squared. Order doesn't make a difference. Plus 1x plus 3x plus 3. Notice my x squared stays the same and my plus 3 stays the same. All I've done is rewritten positive 4x as 1x plus 3x. I chose those because that met the criteria. In other words, positive 1 times positive 3 gives me positive 3. And positive 1 plus 3 gives me the positive 4. Okay, notice what I have. I have 4 terms. So what did we just do in the prior examples? Anytime you have 4 terms, you're going to factor by grouping. So in this case, we're going to put parentheses around the x squared and 1x. And we're going to put parentheses around the positive 3x plus 3. So in the first group, x goes into both. So when I take out an x, that leaves me an x plus 1. When I look at my second grouping, remember sign, I'm going to take the positive 3 divides into both, and that gives me x plus 1. Again, these have to be identical. Since they are, that's my common factor. And my other factor are the 2 values on the outside of the parentheses. So my final answer is x plus 1 times x plus 3. Order doesn't make a difference. If you wrote x plus 3 times x plus 1, it's the same thing. Okay, so let's look at the next problem. Follow the steps. So again, first step in factoring is to remove the GCF. Nothing divides into x squared minus 7x and minus 8. So after I've done that, I'm going to use the AC method of factoring. So I'm going to take my leading coefficient, which is 1, times the coefficient of my last term, which is negative 8. So 1 times negative 8 equals negative 8. Next, I'm going to write the possible combinations. So to get a negative 8, it's 1 times negative 8, negative 1 times 8, 2 times negative 4, and negative 2 times 4. So those are all the possibilities. Now I'm going to add these together. The first one would give me a negative 7. The second one would give me a positive 7. The third would give me a negative 2. And the last one would give me a positive 2. So I'm going to choose the factors that add to give me the middle term. My middle term is a negative 7. So I'm going to choose the positive 1 and the negative 8. Next, I'm going to rewrite the middle term using these factors. So it's going to be x squared plus 1x minus 8x minus 8. Next, I factor by grouping. So I'm going to group the first two together and the last two together, sign and all. So in the first group, x goes into both x squared and 1x. When I take out the x, that leaves me an x plus 1. In the second group, remember, this is a minus 8x. So I'm going to take out a negative, and the value that goes into negative 8 and negative 8 is negative 8. Keep in mind, I'm dividing by a negative, so the signs are going to change. So negative 8x divided by negative 8 is just x, and a negative 8 divided by a negative 8, a negative divided by a negative is a positive. Notice again, what's inside parentheses, exactly the same. That's our greatest common factor. And the values on the outside will be what's left when we divide that out of each. So our final answer would be x plus 1 times x minus 8. Our next problem. Step number 1 is to remove the greatest common factor. Nothing divides evenly into 1x squared, negative 3x, and positive 1. So we go to our next step, which is to use the AC method. So I'm going to take my leading coefficient, which is 1, times the coefficient of my last term, which is 1. So I multiply 1 times 1. It gives me 1. Next, I'm going to write all the combinations to get a positive 1. So I can get that by multiplying 1 times 1 or negative 1 times negative 1. So next, I'm going to see which of these two add to give me the middle term. So 1 plus 1 is 2. Negative 1 plus negative 1 is negative 2. Okay, so now there's a problem. Neither one of these two add to give me a negative 3. If that happens, then that means this polynomial is not factorable, or we call it prime. Okay, so let's talk about the shortcut real quickly. So what I like for you to do throughout this course is to make observations based on what you see. So when we looked at our first problem, the x squared plus 4x plus 3, notice what two factors we chose to give us the middle term, the positive 4. That was a positive 1 and a positive 3. Look at your final answer. Your final answer is x plus 1, there's your positive 1, and x plus 3, there's your positive 3. So the second example, x squared minus 7 minus 8. Look at the two factors we chose to give us the negative 7. It was positive 1 and negative 8. Look at our final answer, positive 1 and negative 8. So the shortcut is, once you've identified the two factors that add to the middle term, you don't have to go through the steps of factoring by grouping. You said, well, then why did you show us all of that? Well, this only works when our leading coefficient is 1. So when you have a 1x squared, it will work. But if this is a 2x squared, 3x squared, 4x squared, 5x squared, then you have to use the AC method or a different method. You can't use this shortcut. So let's go ahead and drive the point home and look at a couple of examples to see if we can use the shortcut. Okay, so no matter if we use the shortcut or not, the first step is always going to be to remove the GCF. So I want you to get in the habit of looking at the problems and asking yourself, does anything divide into x squared minus 5x and minus 6? Okay, in this case, nothing does. So next, again, we're going to think of that AC method. So we're going to take the leading coefficient, which is 1, times the coefficient of the last term. So 1 times negative 6 is negative 6. So I'm going to write all the ways to get negative 6. Okay, I'm going to add them together. So 1 plus -6 is -5. -1 plus 6 is 5. 2 plus -3 is -1. And -2 plus 3 is +1. My middle term is a -5. So that means I would have chosen the first combination. So I can go directly into my factoring, and it will be x plus 1, because that's a +1, and then times x minus 6. Okay? If you don't understand shortcuts, you don't have to use it. It just will come in handy later on, especially when we get into the next module. Okay, so let's do another example. So in this case, x squared plus 9x plus 20. So the first step is going to be to remove the GCF. Nothing divides into all three of these. So now I'm going to use the AC method. I take my leading coefficient 1 and multiply it times +20, and that gives me 20. And again, I'm going to write all the combinations. Okay, then I'm going to add them together. And choose the pair that adds to give me a +9. If there weren't any, then it wouldn't be factorable. So in this case, 4 and 5. So that means a +4 and a +5. So inside parentheses, I have x plus 4 and x plus 5. Now your signs. Notice that 20 is a +20. That means my signs have to be the same, because the only way to get a positive answer is to multiply a positive times a positive or a negative times a negative. So that last sign tells you whether your sign should be the same or opposite. Because notice in the previous problem, this was a -6. And notice I'm multiplying a positive times a negative, which gives me a negative. Okay, so then now that I know that since this is a +20, my signs are the same, how do I know if they're positive or negative? All I have to do is look at my middle sign. Since that's positive, it tells me that both of these would be positive. Next example. Okay, so right away, just to drive that point home, I look at the last term. It's a -7, so that means my sign should be opposite. Okay, so first step, remove the greatest common factor. Nothing divides into x squared, 6x, and -7. So I go to the AC method. So I'm going to multiply my leading coefficient, which is 1, times -7, and that gives me a -7. Now I'm going to write down all the possible ways to get -7 and then add them together. I'm looking for the pair that adds to a +6, and that would be a -1 and a +7. So I can just go directly into my factoring, -1 and +7. Keep in mind what I said also, order doesn't make a difference. So if you wrote +7 and -1, exactly the same. Okay, let's throw in a second variable. So again, process is exactly the same. So the first step is to remove the greatest common factor. Nothing divides into all three of these. So now I'm going to go to my AC method. So I'm going to start by multiplying 1 times -12. And that gives me a -12. Now I'm going to write down all the possible ways to get a -12 in multiplication. -1 times 12, 1 times -12, -2 times 6, 2 times -6, -3 times 4, and -3 times -4. Now add these together. So the first one would give me 11, the second -11, the third 4, then -4, then 1, and -1. So if you look at your middle term, the negative xy, remember, there's an understood 1 to be in front. So I'm going to use 3 and -4. So I know it's going to be x plus 3 and x minus 4. Now, how do I account for the y squared? All I have to do is simply put the y at the end. Because when you think about it, when I multiply positive 3y times negative 4y, positive 3 times negative 4 is negative 12, and y times y is y squared. The xy in the middle will come about if you want to check using the FOIL method. So for instance, when I multiply this x times the negative 4y, that's going to give me negative 4xy. You see the xy in the middle? But same process. Use your shortcut. Practice. Okay, now let's get into ones where our leading coefficient isn't 1. So the steps are still going to be the same. I'm going to look to see if anything divides into all of my terms. So I would be removing the greatest common factor. In this case, nothing divides into 5, negative 33, and negative 14. There's no common factor. So that means I'm going to take my 5 times my negative 14, and that's going to give me a negative 70. Okay, so you're going to write down the factors of negative 70, or you can kind of make it simpler if you want. So I'll start by writing some of these down. I'm not going to write them all down. 1 and negative 70, negative 1 and 70, 2 and negative 35, negative 2 and 35, and then you'd go to 5 and 14, etc. But I could stop here, and you can stop anywhere that you see the answer. So in other words, when I look at the first two, that would give me negative 69. When I add them, negative 1 and 70 is 69. 2 plus negative 35 is negative 33. So that's the pair that I'm going to use. So let's go back to the AC method. So the next thing I do is rewrite. So this is 5x squared plus 2x minus 35x minus 14. So remember, when you're rewriting, the first term stays the same, the last term stays the same. All you do is use the two factors from over here that add to give you the middle term. Next, you factor by grouping. So I group the first two together and the last two together. In the first group, nothing divides into 5 and 2, but both terms have an x. So I'm going to take out an x, and when I do that, that's going to leave me 5x plus 2. For the second group, remember, since there's a negative in front of the 35, I'm going to factor out a negative. And the greatest common factor of 35 and 14 is 7. So when I take out a negative 7, remember, since I'm dividing by a negative, it's going to change the signs. So negative 35 divided by negative 7 is positive 5, and I still have my x. And negative 14 divided by negative 7 is positive 2. Notice again, this will always be the same. That's your greatest common factor. So when I take out my 5x plus 2, that's going to leave me with x minus 7. This may look easy or it may look difficult for some. In either case, practice will make it perfect, and you'll need this for the next module. So make sure you spend ample time practicing. So let's look at the next example. So 3x squared plus 8x minus 3. So our first step in all factoring problems is to remove the greatest common factor. Nothing divides into all three of these. So next, I go to my AC method. So I multiply 3 times negative 3, and that gives me negative 9. So I'm going to write the factors of negative 9. And then I'm going to add the factors together and choose the pair that adds to my middle term. My middle term's a positive 8. So I'm going to use negative 1 and positive 9. So I have 3x squared minus 1x plus 9x minus 3. Factor by grouping. In the first group, nothing divides into 3 and 1. So I look at my variables. They both have an x, so I can take out an x. And when I do that, that leaves me 3x minus 1. For my second group, since this is a positive in front of the 9x, I'm going to factor out a positive. And the greatest common factor of 9 and 3 is 3. and I'm going to divide that. So positive 9x divided by 3 is positive 3x. Negative 3 divided by a positive 3 is a negative 1. Again, what I have in parentheses is identical. That's my greatest common factor. Once I divide my greatest common factor out of each, it will leave me with an x plus 3. Keep in mind again, you can always check your answer by using the FOIL method. My next example, we're going to go about it the same way. So my first step in all factoring problems is to remove the greatest common factor. In this case, 5 divides into all 3 of these. So what I'm going to do is factor out the 5 to begin with. So when I take out my 5, I divide it out of each term. So that's an x squared plus 7x minus 18. Okay, so in this case, which was 1 out of 10 problems, but still when it occurs, you need to make sure you're ready. So always do step number 1, remove the greatest common factor. Okay, so now what do I do? Now, how do I know if I can go further or not? If you look inside your parentheses, if this is a quadratic, that means x squared. It doesn't mean for sure you can, but there's a possibility. So what I recommend doing is I circle this 5 and move it down. So it will be a part of my final answer one way or the other. So if what's inside parentheses doesn't factor further, that would be your final answer. But now what I want you to do is only concentrate on what's inside the parentheses. So we're going to look at x squared plus 7x minus 18. And hopefully you said, oh, my leading coefficient is 1, so I can use my shortcut. So I multiply 1 times negative 18, and I get negative 18. Now I'm going to write down the factors of negative 18. So negative 1 times 18, 1 times negative 18, negative 2 times 9, 2 times negative 9, negative 3 times 6, and 3 times negative 6. So I get 17, negative 17 when I'm adding. Negative 2 plus 9 is 7. Negative 7, negative 3 plus 6 is 3, and 3 minus 6 is negative 3. So my middle term is a positive 7. So I'm going to use the negative 2 and 9. So this factors to x minus 2 and x plus 9. And just to reiterate, how did I know I can use the shortcut and didn't have to go through the AC method? Because in front of your x squared, there's a 1. So since this factored to x minus 2 times x plus 9, all I have to do is put that in the parentheses. So notice the 5's on the outside. That doesn't just disappear. So now if you were to check your answer by foiling, what you want to do is multiply the x minus 2 times x plus 9 using the FOIL method, then multiply your 5 times the answer.